Welcome, everybody. We're going to be working on Module 4 this evening. The topic for the evening is loops. I'm just going to pull up the next slide here so you can see the agenda. So we're going to look at not only looping, but a couple of other little aspects as well. We're going to start out by talking about increment and decrement operators. We are also going to talk about the break and continue statements, which often are part of loops. And then we're going to look at basically four major loop types for this language. I know they show the while loop and the for loop. Those are the two that are probably the most used in programming, but there's also a do while loop and a for each loop. And then we'll also look at the concept of nested loops, which are basically loops inside of loops. Okay. I like this groovy slide here. Notice this very advanced computer system here, old Commodore computer. And if you're curious, a lot of us like old techies like started out on really, really bad systems like this. And notice how there's a cassette player on the left side of the keyboard, right? That's not to listen to music. That's how you would load your software and save your files back then. They would have a tape drive to run the operating system, load up software, save information. Really bizarre. I had an Apple IIe that had a cassette drive. I rarely ever used it. I thought it was really bizarre. But it had floppy drives and no hard drive, if you can imagine that. But we have come a long way, folks. So even though that looks like a really primitive computer, it's probably a black and white screen or a green screen kind of thing. It was really quite a revolution back in the late 70s, early 80s when you were able to buy computers for personal usage. That was right around the same time we were starting to buy game consoles as well, right? Yeah. Okay. They weren't really consoles. They were like Pong with like two variants of Pong, like the double paddle Pong or the single paddle Pong, And yes, I owned one, right? Because it was like back then it was like, oh my God, I have to have one. But we have come a long, long way since then. But it did spark a revolution that by the time you guys were born, right, you were probably born into a world that was internet driven already. People had gaming consoles were a thing, computers were a thing, right? So there, but we did come a long way in a very short period of time. And mark my words, right, as you guys look into your futures, that the stuff we're learning today, even though it's pretty advanced, in the future we'll look back on it and go, oh, remember when I was just using a i7 with 16 gigs of RAM? Oh my God. And I was able to do everything I needed to do, right? And we'll laugh back at it for sure, right? We are, I think, on the precipice of another huge explosion in technology. And part of the only thing that's really throttling us back right now, I think, is the pace of development of the CPU, right, and its limitations. But once they break through that architecture with quantum computing, we'll really see some changes. All right, so that's enough of my little sideline. Let's get into some coding stuff here, and let's look at a couple of really important concepts. And some of these we've sort of been using already, albeit mildly, but today we're looking at them formally. So we have these two words, right? So we have increment and we have decrement. And basically, as the words imply, increment is to increase, decrement is to decrease, right? But when we're incrementing, there's more of an implication that we're just counting by one, right? So think of yourself as like the person who's like standing at like the baseball stadium with like a little clicker every time you walk through the gate. Press a little thing and says, aha, 42 people have come today or whatever. Or if you've ever thought about it in that capacity, that you're just incrementing a little bit of value each time, but just a count basically. We've already worked on doing increments to variables by simply adding one, right? So I highlight the first statement here because this is the traditional approach. If I want to add one to a variable I already have, I say the variable name, I add the one, and then I save it back to the same variable, right? This is very normal. That syntax can be, cut down by using this combo operator. And I'm not really even sure what the formal name of it is, and I apologize, but I always call it plus equals. That's the way I refer to it. But this statement here is essentially the same as this one. We are taking one, we're adding it to, and then assigning it to number. And I will say that most experienced programmers, when they're doing simple increments or decrements, are using this syntax. The plus equals is kind of the go-to in modern programming. Now, if you guys have ever heard of the language C and C++, which are, I should say, are in plural, the parent languages of the C# language we're learning about today, C++, one of the ways it got its name is from this operator, which we're about to learn, which we do call the increment operator, which is the plus plus. So the process of doing increments is so common in programming when you're just keeping a count of something that in C++, they decided they would add this operator so you could take any variable that's a number, namely an integer, put the plus plus after it, and that in essence does the same as this statement, which in essence does the same as that statement, right? So we're just adding one is what this says. All right. So very, very common to use. I think these days when I see most people programming, though, they tend to still go to this one more often than they go to the plus plus. But if you're an old school C++ person or a Java person, you use this a lot, right? And so put that one in your arsenal. It's very handy and useful, by the way. The same way that we can do increments, we can also do decrements, or to decrease by one. And same basic formulas, right? Or same basic types of statements, I really should say. We can take number minus one and then store it back in number, or we can shortcut that operation by using the minus equals operator, right? And as you might suspect, I can use the minus minus to do a decrement, right? So that works also. So think about this. What are situations where you're incrementing? What are situations where you're decrementing? It's usually when you have something repetitive going on, right? So I gave you the example of, like, let's say you're the guy at the baseball stadium that's counting the people coming through the gate, right? Well, okay, there's one, there's another, there's another. It's going to keep going, right? How long is he going to keep doing the same operation? Well, either everybody that's coming in is coming in, or the game is over, right? I mean, he's going to keep doing that same operation, or until his boss tells him to go home. Hey, it's the seventh inning stretch. Go home. So I think it's kind of interesting when you think about it that way, because we use these tools often when we're doing repetitive actions to count up or to count down, right? Decrement operator, like if you were doing a countdown to launch a rocket, for example, you would repeatedly keep subtracting one until you got to zero and the rocket was launched, right? So these increments and decrements often coincide with repetitive code. All right. Interesting thing, a lot of people don't know about the plus plus or minus minus operators are the fact that you can do them either postfix mode or prefix mode, which is really kind of weird. All right. So in other words, I can say number plus plus, or I can say plus plus number. In essence, they both do the same thing. Both are adding one to that variable, but it's a matter of how it's done, right? So what is the difference? All right. So it says here, if it's used in isolation, there's no difference. In other words, if I'm just adding one to a value, whatever, it's adding one to the value. It only matters when it's combined with other operations, right? So notice here, we set an integer to the number 4, and then we console write line. In fact, this might be a good one to kind of demo. So let's go ahead and create a blank console app here. You guys feel free to follow along if you want. If you just want to watch, that's absolutely fine. So I'm going to call this, let's see, mod for examples, I guess. And let's put it in the correct folder. All right, so I'm actually going to copy this code and show you what the difference of this is. What's fascinating about the code is the console write line really is a combination statement, right? So it can output stuff to the screen, but it can also execute the code that's in between the parentheses. And this is kind of the point of this. So I set my integer to 4, and then I do write line number plus plus, and then I do plus plus number. So what output do you think I'm going to see on the screen here? Let's make some predictions.
For the first one, you may see an increment of 1, possibly, so 5.
Really, really quiet, Anthony. You're on the verge of inaudibility for me.
Can you hear me now?
Yes, I can hear you now.
Okay.
Verizon commercial.
I was for the first one, I'm thinking that you see an increment of 1, maybe 5, because it's just the plus plus. Or well, I'm also thinking that you may see a repeated number.
All right. So you think that it's going to output 5 the first time.
Right.
What is it going to output the second time?
A repeated number? This is our guesses.
A repeated number. So you're saying it's going to output 5 again?
No, 4.
Okay. Even though it's increment. Both of these are going to increment.
Okay.
All right. So this is Anthony's guess. All right. I'm going to run it. I think you'll be a little surprised at the results here. So let's see what happens. Yeah, interesting, isn't it? Yeah. So what actually happened here in the output is it did the console write line. And what's the first part of the statement is, what are we write lining? The number. And then it increments it. So when the statement's done, it's 5, but it displays 4. So then when it hits this statement, the value of number is already 5. And then we're adding 1 to it and then displaying it. So the output becomes 6. So the output is actually 4 and 6. Pretty weird. Now, if I'm just doing like really basic math operations, so I'm going to just give you an example here. Oops, wrong line there. I'm going to comment out these 2 write lines, and I'm just going to grab the number plus plus, and then I'm just going to write line it. And I'm going to remove the plus plus from the. What will this output?
Is it 6?
All right. So keep in mind, these are blotted out now, right? So
Oh,
start with
I
4.
see.
We're going to add 1. So it becomes 5, right? And then we're going to output it. So it's going to output 5. Right. Now, an interesting thing, and we're not going to dig super deep into this, is you can also set breakpoints in your code. So we haven't learned this technique yet, but we're going to start experimenting with it a little bit as we go. But you can do what we call breakpoints that you can put in your program that can stop the code in progress and show you what the value of everything is along the way. But this is one of the perplexing parts about working with these operators. When it's standalone like this, it's a lot easier to see what it's doing than if it's kind of doing it as part of another operation. It gets a little more convoluted, is a polite way to say it. All right, let's close this little console window here. All right, so that's kind of the lay of the land with this. So this would output the number 4, then add 1, then it would add 1 more, and then output the number. So 4 and 6 is the answer to that one. All right, and that's what they're making the point of here, right? The statement above does 2 things: prints the value of the number and then increments it. So really that plus plus operator is kind of a separate thing than the variable it's attached to, right? So remember that the plus plus is the same way of saying plus equals 1. So that's really what it's replacing. So the fact that it was so common that they decided to write these into a language like this I think is fascinating, right? Because it's such a common operation. All right, so they just explained it here. Printing happens first because the increment operator is in postfix mode. Changing to prefix mode makes the increment happen first. And if you are using this and you're combining it with other statements, you need to be mindful, basically, of if you're going plus plus after or plus plus before or minus minus before or after. All right, so that's our increments and decrements and the plus plus minus minus operators. Next thing we're going to do is talk about loops. And before I dig into talking about them formally, what I will say about loops basically is that we've learned so far how to code basically using a series of different types of procedures, if you guys recall this, right? So basically 3 ways to solve logical problems, right? One is called sequence, right? Which is step by step. Maybe I should make that a little bigger. The second that we learned is selection. We can say AKA decisions, like the fork in the road, the if statement, the switch statement, right? Where you're not necessarily going to always follow the same path. You're going to follow the path that makes sense to your logic. And then the third one is what we call repetition, right? Which is basically looping or repeating code, right? And it's said with these 3 techniques, we can solve just about any logical problem. There's one, at least in coding, that's not really included here that really technically should be, which is one called recursion. And this is, I'd say a higher level function. And that's what recursion is. It's code that calls itself. It's like kind of like looking in the mirror and then you got a mirror behind you, right? It's like the mirror reflection with like, which reflection are you looking at? And it kind of goes into infinity in a different way. But as it goes into infinity, it becomes a more primitive copy of itself. It's kind of like a weird thing, but that's a technique too. I would call this a much higher level type of concept. It's not that you can't use it without understanding it, but it is typically related to complicated math algorithms. But I think what's really fascinating about recursion as a concept is that's the pattern that nature uses, for example, to replicate DNA, where DNA becomes a replicant of itself. And you see the patterns of recursion in nature, like how a plant grows, like really goofy stuff like that, or how cellular division happens in a body, right? So, all right, so let's go ahead and get that off the screen, but that's just kind of to give you an underpinning of where we're moving to in terms of the concepts of programming. So a loop, very simply, is part of a program that repeats. So it's a block of code that will keep repeating itself and running over and over again. C# has 4 major loop structures: the while loop, which is what we call a pre-test loop. We'll learn about that. And then there's a do while, which is what we call a post-test loop. So the while loop tests at the beginning, the do while tests at the end. Then we have the for loop, which is one that I like to think of as kind of like the predetermined loop structure. So like when you're going to run the loop X number of times, that's kind of the one you go to. And then you have the for each loop, and notice there's a little asterisk next to that one. The for each loop is what I think of as kind of like an automatic loop. So it's built to traverse complicated structures. So if I had like a list of 1,000 items, I could write a for each loop that would automatically traverse it. And then if a couple items got deleted, it would automatically adjust. I wouldn't have to change my code to adjust for the length of the data that I'm working with, right? So those are generally the categories. Now, if you look at these as overall categories, the do while and the while are basically one category, and the for and for each are different. one. These are just slight variations on each other, right? For and for each the same. And it does say the difference is how they control the repetition, and that's absolutely true. The other thing that I like to point out to people is often when you learn how to do looping, you will very quickly discover that just by writing your code a little bit differently, you can probably make all the loop structures do what you need them to do with the right logic applied. You know, that's the other aspect of it. Although some generally are better suited for certain situations than others. All right, so we'll start by looking at the while loop. And that's very typical in programming to look at that loop structure first. Notice as we kind of look at the flow chart on the right there, that it looks a lot like an if statement in a way, right? You get to this diamond shape, which is the true false checker, basically. And you ask the same kind of question you would ask in an if statement. You know, is X greater than 5? Or does, you know, the user input equals Z or something goofy like that. And then you get a true false answer, right? If it's true, then you step into the loop and you execute whatever statements are inside the loop. Like an if statement, if it's more than one statement, curly brackets. Singular statements don't need it, but more than one statement, curly brackets. So generally a good idea to put them in, but you would repeat those statements. And then after you're done repeating them, then you go back up and you check, is the statement still true? And if it is, you keep running the loop. Now, the problem with these, and we'll have a slide on this, is that you have to make sure you change some values usually inside here, usually with an increment or a decrement, in order to change the Boolean expression so you can someday come out of the loop, right? Because you can get stuck in a loop too, right? So that's kind of interesting. If you check the expression and it's false, then you're out, right? All right, so let's take a look at an example. All right, so here I want you to notice that we start this while loop by first initializing a variable, right? So in other words, I'm setting up a variable called number that's going to hold the number 1. It's an integer. And then as I go into the while loop, I'm checking that variable against this statement. And I'm saying if the number is less than or equal to 5, then if that's true, we'll do this stuff inside the curly brackets. And so there is that like word if happening there, really, right? So while this statement is true, keep executing this code. So it's going to output hello, and then it's going to increment the operator, right? Or what, you know, we'll learn is called the loop control variable, technically, right? And so this value gets incremented by 1. It came in, it was 1. We output hello, it becomes 2. We go back up, 2 is less than 5. We output hello. It becomes 3. 3 is still less than 5. Hello. Now it becomes 4. 4 is less than 5. Hello. Now it becomes 5. Still 5. Still going to do it. Hello. Now it becomes 6. Now the statement is false and we pop out. How many times did hello print? Yeah, if you guys aren't sure, yeah, you know what? We have Visual Studio sitting right here, right? So we can just drop it in and let's try it out, right? So I think, Anthony, you put up 6 fingers. All right, let's see if your guesstimation is correct. So hello, 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 hello. That's 5. That's all. Yeah. But these are kind of goofy little things. How you set up the statement that you're checking is really important. Now, if this value is hard coded, right, like we did, right, we basically hard coded that value to start the loop. We basically forced the loop to run with the logic that we used here. But what if this value is based upon user input? Right? And they typed 6, right? This loop would never run. Right. So these are considerations that you make with while loops, by the way. All right, let's go back to the slideshow here. All right, so let's talk about a little bit of terminology. And you guys have probably heard the phrase reiterate, right? Most people in normal speaking English don't say, hey, I plan on iterating my code at least once. And I'm being very goofy here because it's very nerdy sounding, right? But iteration is the process of iterating. Iterating is the process of doing things over and over again. A single instance is a single iteration. And then the process of doing it is to iterate. And if you're doing it over and over again, you're reiterating. So see the terminology. All right, so it says each repetition of the loop is called an iteration. The sample loop performs 5 iterations. Okay, breakpoints can help us visualize the loop running. All right, what happens to the value of number as the loop repeats? All right, so we are going to add a breakpoint, and here's what I'm going to do is right here at this particular point, I want to add a breakpoint. And basically what a breakpoint is in code is it's telling the program to stop here when I'm running it. Execution will go and then it will stop and it'll not proceed until I tell it to keep going. Now there's some values of this. So I think it's better to just do it and then you'll see what I'm talking about here. And then you'll notice also, as I'm doing this down here at the bottom of the screen, it's showing me my variables. I ran the code, it printed hello, and then it stopped here. I want you to notice this is post-fix. So at this point, when it hits this line of code, the value of number is 1. Right? All right. So if I hit continue, and I wish I could keep them both on the screen, it did it again. See, the value is 2, right? And I think you kind of get the point at this point, right? And probably the better way to do it is like this, right? So I can show you both at the same time. And see the value. All right, we got our 5 hellos. Now keep in mind that the moment I step away from here, number is going to increment by 1. It's already at 5. So by the time it comes back up here, it will be 6. Right. And there you go. That's all. But that's how you do a breakpoint. And what's kind of interesting about these is you can actually toggle them from the sidebar and turn them on and off. Right. And these are kind of really handy tools for programmers. If you're running a program, by the way, that has multiple variables, when you hit a breakpoint in a program, you can see the value of all your variables. All of them will display. We just had 1. This is particularly useful when I think, when you're learning how to do loops, and that's why this topic is brought up now. In terms of the practical usage in real life programming, and I probably a lot of programmers will hear me go, what do you mean you don't use them? I tend not to use breakpoints when I'm coding for real, right? I tend to try to figure it out in advance before I need to check it. But there are times, especially when things aren't working right, that you use breakpoints to figure out what's not working right and why it's not working right. Okay, so that's kind of the practical usage of that. All right, so breakpoints are kind of fun. Now, to kind of like keep carrying on with this example, when we're running this loop, we have this thing we call the loop control variable. And so, and as evidenced here, we have a variable called number that happens to be the determining value as to whether or not this loop is running. So therefore, it is the loop control variable. People will call this by different names. So I'm just going to give you a little bit of a heads up on that. but the loop control variable is a fairly universal thing, especially in the Microsoft world, is what we call it. But we are constantly checking that loop control variable to see if it passes the true false test. And the moment this statement becomes false, that variable is the one, basically the one that's changing and controlling that loop. All right. Now the regular while loop, in order for it to execute any of the code inside of the curly brackets, it has to pass the logical test before the repeated code starts. So we call this a pre-test loop. So we're testing first, looping after, but only if it's true, right? And in certain situations, when you're programming, that's just the thing, right? That structure makes the most sense. But you notice, in order for us to even to trigger the loop to run here, that I had to force a value in advance to force it to run. So the decision in this case is strictly manual to make this loop run, but it is a pre-test loop. There are a bunch of different circumstances, right, before you run a loop, and this is where your logic comes in once again, and the situation you're coding for will come into play. But if you did something like this, where I set the value to 10 and I'm looking for the number to be less than or equal to 0, is this loop ever going to run? Yeah, it's not going to, right? So that could be a consideration as to if you code it or not. Now, if this value is controlled by your user and his input or their behavior on the screen, well, then that might be more logical. Maybe you don't want it to run, because they're not smart enough to, or I don't know, whatever. All right. Now, there are scenarios though, right? So what happens if we remove the number plus plus statement? Number will never increase. It'll always stay 1. And then this statement will always stay true. And then we get an infinite loop. And they give the warning. It's very important that if you have a loop control variable and it was triggered to run true when you started, that you have to make sure you give it a way to stop. Otherwise, that loop runs forever, right? Shall we demonstrate? You're like, do I really want to do that? Right? My computer's going to blow up. Yeah, maybe it'll blow up. I'm going to go ahead and do this. I know the risks involved. I think it's amusing to try, right? So let's try, right? The worst thing that'll happen is I'll have to cancel my Zoom session, log out, restart my computer, and come back in. That's the worst, absolute worst case scenario. But I assure you that's not going to happen here. So watch what happens. I'm going to get it to run, and there it goes. What you can't tell is my cursor down here is flashing, and it's like still going. It's like I don't know how fast it's doing it. All right. So the question is, then how do I stop it? Right? Control C, by the way, is the magic key in a console window. If your program does that, right? Well, you know what the other magic key is? The red X in the corner works too. Sincerely. I'm actually a little surprised that Windows allowed us to run an infinite loop, right? But then I'll give you kind of an interesting thought process here. Infinite loops have a place in coding too, like intentional ones. So for example, in my Windows operating system, as I'm moving my mouse around the screen, the Windows OS has a program running infinitely, which is like while Windows is on, scan for mouse movement, right? So, hey, look, Ty moved his mouse from the bottom to the top. Did he click? And basically there's, the point is the user interface of Windows has an infinite loop that runs, that monitors my mouse position, listens for clicks. And if I happen to click and there's something underneath that mouse, it's going to respond to that click. But that loop is running as long as Windows is running. But there is an endpoint. So this is kind of a really interesting kind of thought, as you start learning about loops. What might be a little more interesting here with this goofy loop is, And I suppose I can just do it like this. What if I display the number while I'm running it? So I think this is a little bit more amusing, actually. Now, you guys were hoping to see that number increase, right? But I'm not incrementing it. Right. All right. Let's try something else here. Let's create another int. Let's call it num2. Let's set that equal to 1 also. And then instead of displaying number, we'll display num2, but we'll throw num2 in here with a plus plus, so it increments. And what's that? What is that going to show us? How many times the loop is run? Because I think this is pretty fascinating, how quickly the numbers grow, right? Yeah, I don't know how much you guys are catching the live frame video of this. Yeah, it's like really fast, right? It's already up to like 300, 400,000. Now I wish I was earning like interest at this rate, like 1 penny at a time or something, crazy. No, wait, this is our national debt. Got it. Right. Do you ever see those billboards where they calculate the national debt and right. Okay. So, all right. Kind of crazy code, but examples of infinite loops, and really shows you how fast your computer is processing it too. I think it's profoundly cool. So infinite loops can be fun. All right, so they kind of like reiterate the concept here. It says, like an if statement, don't end the while line with a semicolon, right? So don't put a semicolon here. The same as like you do with an if statement. It's the curly brackets that really define the code, right? If you do put a semicolon here, and that okay, so I guess this is the point of the slide. If you mess up and you put a semicolon after the while statement, that will basically create an infinite loop anyhow, right? Because we just like put a loop in with no code inside of it. There's no way it's going to change. So don't do that. That's basically the point. If you do have multiple statements inside of a loop, and that's pretty common that you do, this statement here, if I was to remove the curly brackets from it, it would just infinitely right line hello. Just that's what it would do, right? Because this is not part of it. You do need the curly brackets in there to show that it's part of the same block of code, right? But if you only have a single statement loop, you can omit the curly brackets. What do you think I'm going to recommend? The same thing I do with if statements, is put those curly brackets in, because it'll come back to bite you if you don't. A real common use, by the way, of a while loop is what we use for basically input validation in a program. So like, for example, if you ask your user, hey, and enter the number of Monster Energy drinks you had today, right? We would expect them to enter a number. That would be one thing, right? So we could check to see if something's a number. And if it's not, we could have them enter it again. Or if they were to enter a negative number or a decimal number, we could have them enter it again. So a common use for a while loop is to get the initial value that they're typing in, check to see is the value invalid. So it's wrong, right? So the true would be that it's wrong. We'd show them an error, and then we ask them to enter the value again. So instead of like crashing the program, like, how old are you? Yes, they type instead of their age. We give them a chance to fix it. So this is a really common use of a while loop, is to do stuff like that. Here's another example. If I was at a login screen for any application and it asked me for username and password and it fails. Okay, so what happens? They just take you to a different website? No, they give you another chance, try again, and you have to be careful on those too. But usually like a standard password approach is like you give them like 3 tries or 5 tries, and if they don't get it, then you bump them out. right? Because it's easy to mistype, right? So stuff to think about. Very common usage for while loops. There's this other concept, you know, and that kind of relates back to this slide here. This initial prompt for a value before we check to see if it's valid or not, we typically call that the priming read. So in other words, we are reading in information first in hopes of getting our loop to run or not run, right? And in this case, we're prompting the user for that. So we're putting a prompt on the screen, we're capturing their input, and then we're going to check it, right? So in this case, you know, if they're being prompted to enter their age, we hope they enter a number not less than 0, because that wouldn't make sense. And very highly super unlikely they'll be older than 150, right? Gosh, what are there any beings on Earth that live more than 150 years? Maybe sea turtles or something crazy like that, right? They live a really long time, or like giant squid or something weird like that. But otherwise, if they enter a number outside of that range, right, they're going to, that priming read will reject and the loop won't even happen, right? So we want them, you know, while the age is less than 0 or the age is greater than 150, values that don't make sense, then we will ask them again to enter their age. So this is a way to kind of force them to put in a valid value. That's kind of the point of this, right? So if people are giving you bad information, here's a mechanism. So basically you would take this line of code, which I don't know if you noticed, right, is basically the same as this one minus the invalid entry part, right? So if they can't enter the right information, we just ask them again until they get a number somewhere in between that range, right? So that's kind of a very useful when you're doing user interactions, right? This is stuff that comes with practice, by the way, and you'll see that experienced programmers often will use these tools very automatically when they get comfortable with them, you know, especially for any sort of user interaction, right? So that's the while loop. Now let's take a really quick look at its, you know, its cousin loop, which we'll call the do while loop. And this one is a post test loop. So basically the way the loop works is we execute the statements in the loop at least once. We just run them like a regular steps in a program, right? Step by step. Then at the end of the expression, we check for true and false. If the expression is true, we loop back and do the statements again, come back and check the expression. If it's false, we just pop out. But the difference is between this and a while loop, with a while loop, if the condition is false, it will never execute. With a dual while loop, it will execute at least once. That's the huge difference, right? And so there may be logical reasons to do that in the program. I can't think of one off the top of my head, but I'm sure our examples will kind of help, right? So here's an example do while loop. Now notice how this one will operate, right? We'll set our variable. The statement starts. We start to execute the code. We say, hello, number increments to 2. We check it. Is 2 less than or equal to 5? True. We loop again. Hello, right? And we just keep doing it until that number increments to 6, and then we don't do it anymore. How many times, if I take this code, how many times will it output hello? This is really kind of an interesting little exercise. Yeah, you might want to think about it a little bit. I'm going to go ahead and hit the play button. All right. Isn't that interesting? The same number of times as the other one. Right. So the difference though is, right, if this value was higher, let's say I set it to 10 in the loop, never really hits, it will do it at least once, right? So it'll never pass the true test, but the code in here will still execute at least once. That's the difference on that one. Once again, we call it a post-test loop because the test comes at the end of each iteration, right? We do the statements at least once. Right, and I think we demonstrated that well enough. Now, folks, we are about an hour into class time, so we are going to take a 5-minute break here. So I'm going to go ahead and pause the recording. All right, welcome back. We're going to move on in our presentation now. Now we're going to start talking about the for loop, which is the other major looping structure in C#. I like to think of, the for loop as often like the go-to for experienced programmers in a lot of situations, right? If you ask a programmer, like, what type of loop do they prefer to write, for loops, usually are at the top of the list for whatever reason. Let's read up on what it says here about it, though. It says conditional loop executes as long as a particular condition exists, right? So we're looking at the while loop, right? So while loop checks for condition. If it's true, it runs, whether it's pre-test or post-test. So either a while loop or a do while checks the condition of something to see if we have truth. Often we don't know how long that loop is going to run. I know I was challenging you guys, like, how many times is it going to print hello, right? And that we can kind of determine because that's a pretty simple one. But if the while loop is interacting with, let's say, with user interfaces, I mean, you might just have somebody that just doesn't get it and can't type the right thing in, and that loop might be going on forever, right? And that's one of the reasons why, like, for example, like for a password prompt, you want to end that loop after a while, right? If you give a person an infinite number of guesses, the theory is eventually they'll get it right. Okay, so those are conditional loops. But for loops fall into this other category, which is what we call count controlled loops, where it runs a specific number of times where we know what the value of X is. They're using X as the example. So for example, if I write some code that prompts somebody to enter the sales data for 7 days in a week, well, I know how many times I need to run that because there's 7 days in a week, right? It's not going to be 8 and it's not going to be 6. It'll be the same number as much as that business is open to enter the sales data, right? So, the point here is you could use a while loop or a do while loop for either type of activity, but for the for loop, it's a lot more efficient when you know in advance how many times it needs to run, because it helps you simplify the syntax of your loop statement and the code within it, more specifically. And the little statement here at the bottom, it's like a compact rearranged while loop, and that's not a bad analogy. So let's kind of take this example here, right? So on the left, we have a while loop. We set the integer to 0. We check it. It's going to run because we're forcing it to run. It's going to output X, and then every time it outputs X, it adds 1 to the number so that eventually we can turn this condition to false and pop out of the loop, right? Now, let's take a look at the for loop. And as you're seeing it here, and I'm a little uncomfortable with the way it's expressed, but it's the way it's expressed. I want you to notice that there's 3 statements inside the top part of the for loop. One is it's setting the loop control variable here, not before the statement, but inside the loop. We're declaring it as an integer. We're setting its value. Then there's a semicolon. So it shows you that this is really a standalone statement. Then we're setting the true false criteria. So for as long as that number is less than 5, the loop will operate. Every time we run the loop, we will execute this code at the end, which is to increment the number by 1. So all the logic is contained in the declaration of the for loop, and then the code inside of it is just simply console write X. It'll just write X over and over and over again. Okay, so a little bit different structure. All right, so let's take a look at that statement. And on this slide, it looks like more like a normal for statement. And that is with those three declarations written across one line, right? So it says the first line is the loop header. So this whole first line is what we call the loop header, right? And notice it says commonly written as a single line. There are those people that write it like this. I hate it like this, by the way. I'm just not used to it. You know, real frankly, this is how I'm used to seeing it. And it says it contains all the important loop pieces, the loop control variable, the logic, and the increment or decrement that we need. And then that frees up the middle of the statement, you know, the middle of the curly braces to just be focused on the activities rather than worrying about incrementing that variable because it happens up here. Right, so you can see why that can be a little bit easier syntax. And what I find is that when you use for loops, you tend not to have as many accidental infinite loops is what it is. All right, so the first part of that three-part expression in the parentheses is what we call the initialization expression, right? So this is where we set up our loop control variable. It's written in at the top. It only happens once when the loop starts. It doesn't happen every time it runs. So this is kind of like what happens before the loop, right? The next statement is what we call the test expression. Like a while loop, it's checking for true or false. So it's not that we're eliminating that piece. It's just built into the statement. It's the middle part of the statement. We still need it to be true in order for the loop to keep iterating. The final part of the expression is what we call the update expression. How are we changing the loop control variable in order so that we don't get stuck here forever? Right? What is the mechanism that we're using to change? And since most loops tend to increment or decrement by one, very typically, we just put that increment or decrement right in the statement. All right, if you have the question, of course, could I say number plus equals 1? Sure, you can do it that way. This is more common, by the way. Right, if you look at a graphic of how a for loop would operate, right? So we assign 0 to the number. That's our loop control variable. Seems to be happening before. It checks for true or false. We assume it's going to be true since we're setting it up to run, right? It'll print and then it'll increment the number. So, I mean, really the pseudocode is not altogether different, right? I'm not sure what they're trying to say here in terms of pseudocode in C#. So if you switch it to C#, here's the language, just so you can correlate that basically this box, and this box are all part of the for loop header, right? But when you loop them this way visually, it looks like they're not. It looks like a while loop in this capacity because functionally it is basically doing the same thing, right? So like it says here, like the while loop, for loop tests its condition before executing the statements. So if you set up your logic incorrectly, notice I'm putting my loop control variable in a range where it's never going to flip to true. It will never run. So you can still screw these up. So in other words, you can set up the logic so it doesn't make sense relative to what you're doing. That's on you, the programmer, to figure that out, by the way. All right, so here's a little warning. The loop control variable is modified in the loop's header. It's a bad idea to also modify it in the loop body. But it does happen. People like switch from while loops to for loops and they forget about that. So if you're trying to change that loop control variable inside the code block, inside the curly brackets, not a good idea. Not that you can't do it. You can do it if you want, but it really might break your logic quite a bit. So just be mindful of that, basically. Notice it says you're not limited to incrementing, in other words, plussing the control variable. You could also, for example, add 2 each time. This is kind of a thought, or 5. You want to count by 5s? You want to count by 2s? You want to count by thousands? You can do that, right? That's totally allowable. Just make sure your logic is set up to do it correctly. So with this loop, right, the first loop, we're setting our loop control variable to 2, the x. Now we're testing is 2 less than or equal to 100. That's true. And then we'll right line. And then it'll increment by 2. And each time it right lines, it's going to right line the value of x. What's that going to print? First for loop there. If your brain is saying, well, it's going to print all the even numbers between 2 and 100, that sounds correct to me. Right. And you know what? This is easy enough stuff to try when you have your IDE sitting there, by the way. And we should terminate that program. But it's easy enough to just dump it in there and run it and see what happens. Yeah, and if I scroll up, you will see it did exactly that. 2, 4, 6, 8, 10, et cetera, et cetera, et cetera, until we got up to 100. All right, so seeing how that one works, what's this one going to do? We start a number at 10. Notice the flip of direction here. As long as x is greater than or equal to 0, we'll output the number. And then each time we will decrement. We're going to reduce it by 1 each time. So what's this going to print? Yeah. All right. If you're racing to unmute your mic to say 10, 9, 8, etc., all the way down to what? What's the last number it would print? It's counting down is what it's doing. But will it print 0? It will print 0. Right. Let's try it. It's really easy to try. Right. Since the code's right there, let's just drop it in here and run it. So here goes. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. But but notice how the sign was flipped, and then we switched from decrement. We went from a large number to a small number. Right. So we can count up or we can count down. We can do either one. All right. So the important point that they're making on this slide here is that for loops are really good when you know how many times you want to run a loop. Okay. And we call it counter controlled. But what if we let the user enter the X, right? And so we do something like this. How many squares, right? And then we grab it, convert it to an int, and store it, right? Would the loop run? Well, we don't know what loop it's going into, but if we are controlling a loop with user entry, we really are running into a risk here, right? What's the risk? That they're not going to enter something that makes sense, right? Okay, I could write a loop to circumvent that, I suppose, right? But notice what it says here. Number entered by user determines when the loop ends. But I think there is a risk to this, so be careful with this. So what's the number here that they're checking? Yeah, this gets a little weird because really num is the loop control variable, right? Because we're declaring it here and we're incrementing it there. But we're comparing it to an unknown value. And really what they should have said here, yeah, well, they're calling it max. Okay, so they did say it there, right? Is the user's controlling that number. But as long as the number is, greater than 0, right? This loop will run, right? This number starts at 0. We assume they're going to enter a larger number. And then it's going to console right line this. This is kind of a fun one to run. So what does this one do? It takes the number and it squares it, but now we're also looking for input too. So if you guys want to get the input part of it in there, you could grab the code from here. So we'll have to do that before the loop. So that's a doable thing, right? So let's run it. And I'm not going to do a lot here, so I'll just say 10. And then what did it do? Oh, did you guys catch what I did? I put a loop inside of a loop. All right, not what I meant to do, by the way. But interesting output, wouldn't you say? Yeah, not what I meant to do at all. All right, let's run this. All right, let's make it a little more interesting. Yeah, so there's the output on that. So what might break a program like this, or what value would you have to enter to not have it work at all? How about a negative number? That would be 1, right? So that's kind of one of the dangers of user controlled for loops, but not that it's not possible. It can totally work for sure. All right. Now, one thing I don't see a lot of people doing this with loops. It's usually pretty advanced programmers, but it is possible in the initialization and update steps to assign more than one value. So if you're working like with an X and a Y and you want to declare them just like you would any other integers, you can do that. And like I said, I wouldn't call this typical, but I do see people doing it. Right? And then can you increment more than one value at a time? Yes, that would work too. Right. So that's a possibility. All right, I think we played enough with the example loops, but we kind of did the even numbered thing already, right? Because that was one of the examples. How about create a loop that displays all numbers between 11 and 34, including 11 and 34? I think that would be a good one to try. I'm just going to copy that so I just remember the instruction. All right. So if I was to engineer this, help me engineer this. Can I use the values that are here? Well, how about I start with num and call it 11, right? And we're going to run that up until number is less than or equal to 34. Would that work?
Yes.
And then, of course, we would have to change the statement, correct? Let's just get rid of all this unnecessary stuff here. And I'll just say num equals whatever it is. Would this do the work? Don't all rush to answer. It's okay. Yeah, that works. So 11 to 34, including 11 and 34. If I wanted to not include 34, I want to go up to 33. I'd get rid of the equal sign, right? If I wanted to start at a different number, I would change my loop control variable, right? All right. So that's just a little bit of practice with the for loop. The other thing that we might want to try is this other little exercise here. How about create a loop that displays all the numbers between 56 and 3 inclusive, counting backwards. So 56 and 3. So could I preset this to 56? Right? And then do I need to flip the sign? as long as the number is greater than or equal to, was it 3? Right? And then instead of incrementing each time, I would decrement each time. I would reduce it. Right? So that's how I would do that. But this is kind of like goofy stuff, right? From 56 up. You guys all thought it was going to work, right? I need to go down to 3. Why didn't it work? Correct. You have to put the equal sign here because we stopped before we got there, right? And I'm doing it backwards. It's got to be greater than or equal, not equal or greater than. And now you'll see 3 included in the output. So 56 down to 3. And so that's some more little basic examples there. All right, let's try to attach this to some more practical, like real world situations here. So here's an example of a sales total program, very common, by the way. Like, think about this. When somebody's working a cash register and it's at all electronic, where it's storing information, they turn that thing on when they like log into work or whatever. They log into the register, if that's what kind of register it is, or if it's an old school kind, they put the key in and they turn it on, right? And make sure they got like receipt tape in there. And then all day long, they're processing customers and they bring up a sale and they ring up another sale. And whatever that total amount is that they're ringing up, somewhere in that cash register, it's being accumulated, right, to a sales total, right? So very common type of business activity, by the way. So having the need for a program to track total sales, the salesperson enters each sale. When they're done, the program calculates the total, right? And think about the cash register. If you've ever worked one, right, and you were responsible for closing it out at the end of your shift, there's probably like a special mode you go into and you hit the total button and it prints out what your totals are, right? And that's kind of what we're going to do here. The question becomes, how do we store the sales amounts to get the total? That's one thing. How does a salesperson indicate they're done entering the sales? Okay, 2 problems that we have to kind of address, right? So we're going to have to store some sort of a running total, right? So we're going to need a loop that reads the sales amount. So like, enter sale number 1, enter sale number 2, that kind of thing. A variable that's going to hold the total. And notice the word accumulate, right? And this is kind of another one of those, IT concepts. We call this an accumulator, right? When we're grabbing values and we're just adding, right? And with sales, that's what you want. You want to keep adding your sales up. We're going to start it at 0. And then every time we get a sale, we're going to add to it, right? So the pseudocode for the accumulator then becomes this. We initialize the accumulator to 0. Then we ask the question, are there more sales? It's true or false. If there are, we type in the next amount. If not, or if there is, we add that amount to the accumulator and then we ask, are there more to enter, right? And we keep going until it's false. And we have kind of, the completion of the loop, right? So here's what it looks like in code. We'll start with a total, right? We'll set our total to 0. Now I want you to notice the total is not the loop control variable here. The loop control variable is the sale number. So like, how many sales have you had today, right? So we start at 0, right? Then we'll enter the sale amount. We'll take whatever they entered. We'll store it in the total variable. Then the sale number will increment here. So this is really going to track the number of sales, this, right? And then this will store the total of all the sales. All right. What makes this loop stop? Here's my first question. Well, we're only going to be able to enter how many sales before the loop quits?
A 4. It'd be 4.
Anthony's guessing 4. All right,
4 is
should
the
we
last one you can use.
but we start our counter at 0. We go 0, 1, 2, 3, 4. That's 5. We're always going to be off by 1, Anthony, I think, right? All right. This is a goofy little one. Let's try. Let's just drop this into the IDE and try it. So I'm just going to grab it, drop it in here. All right. So we're going to run it. I do want you to keep in mind the prompts are happening inside the loop, right? As they come up, so we're already inside the loop here. And I'm going to enter the sale amount. I'm going to say, I don't know. I'm going to use very simple numbers. So there's an example of it working. So you could imagine this is a okay scenario. So like if you were maybe entering the total sales for a week, you could force this to run 7 times, right? And then you would have your total amount. So that's one approach that we're using here. And let's go ahead and terminate that. But that sort of little simple program is very, very common in programming, by the way, used in a lot of different things. Another terminology thing which I think is kind of interesting is this concept of what we call a sentinel value. And a sentinel is kind of an interesting word in and of itself, because what is a sentinel generally? Have you ever heard that word? Like anybody who's ever been in the military probably has, right? Right. A sentinel is basically one that keeps watch over things, right? And so think about that as we're doing this. Allow the user to enter as many amounts as they want. How will they signal when they're done? Well, they use a sentinel value. And usually we choose a sentinel value because it isn't one that we would expect a person to enter. So for example, if you're asking a person to enter their sales repeatedly, so that like the example is I made a sale of 97, 85, and -1. All right, well, -1 doesn't make sense. That can't be a sale. That would be a refund, by the way. But if I were to enter in that value, I could trigger my program to stop grabbing values when the sentinel value is added. So in other words, we're looking for the value of -1 to stop the loop from running. So that becomes our sentinel value, right? So when the loop encounters a sentinel value, it exits. Good sentinel values will depend on the program. For sales, maybe 0 or 1 are the values one enter, and either one would make sense. It also has a little thing here. It's important not to add the sentinel value into the accumulator, right? So that's part of the processing you have to figure out, right? So kind of going back to the sales total program, we have some questions to ask, right? So we got to think about this. And this is the kind of question that you ask when you're a programmer, right? It's like, I realize I have to loop here, but which loop should I use? This becomes an issue for programmers. So consider what happens if the salesperson has no sales, and then for the priming read, they enter -1, right? And so like basically we would set up our total thing, set it to 0, that's the accumulator. Then we prompt them and say, enter the amount of the sale, right? Or basically -1 to exit, right? And then we would convert it and then go into the logic of the loop, right? So we have, this is basically then our priming read. Would we ever enter the loop? Well, no, right? And here's kind of the point of this. In the prompt itself, we're expecting the user to enter positive number values, right? Anything from 0 or above, $1, $10, $1 million, whatever. Positive values that we can accumulate into our total. If we show them how to exit, they should know hey, if you enter -1, you're all done entering. And so look what happens here. While the amount is not -1, then we run the loop, right? We take the amount they typed in, add it to the total. Then we prompt again, enter another amount, basically, right? And grab it. Did they enter -1? No, they entered an amount. So we'll add it back in and you just keep doing it until they enter -1. So this becomes a really important value. Then this becomes their sentinel value, the -1. The moment that they enter it, then this statement is no longer true and we're out of the loop. That really good example of a sentinel value in that regard. All right. Why don't we try to code this? It says write a program that repeatedly asks the user for a number until they enter -1. When the user is done, display the total and average of all the numbers that were entered. Right, this is a pretty useful one for getting homework done, by the way, right? Because these are become kind of typical actions. Do not include the sentinel value of -1 in the total and average calculations. All right, so let's see if we can kind of build this. And I think what would be really wise is to kind of borrow from this a little bit. You guys cool with that? So what I'm going to do is I'm going to borrow all this code to save me a little bit of typing here. So I'm going to blow all this stuff away. Yes, I'll do a little bit of cleanup on it, but I'm just showing you that we can borrow stuff here and kind of speedline or streamline our process a little bit. All right. All right. So if we're going to total and average, we know how to do those things, right? But I'm thinking up here, we might want to set up another variable for average. And do we want to, okay, here's the other question. Should the average be an int or a double? Yeah, if you're thinking double, you're correct. Because we might get a decimal number. We just don't know, right? We just don't know. All right. We'll preset that to 0 though, right? All right, so we're just setting that up outside of here. We're going to prompt. We're telling them to enter -1 to exit. We're going to grab that first entry. And as long as it didn't type -1, the loop's going to operate. Do I still need to add the amount to the total? And, we're calling it amount. Let's just change it. Let's call it num, and so all these spots where we say amount, we're going to change it to num because we're really just looking for numbers here. It's not a dollar amount. Right. All right. So we're going to grab that. What other thing do we need to do though to come up with an average? Think about this. An average is you got to count out, you got to add all the stuff together and divide it by the number of times. So we need a counter also, right? So I'm going to come up with another int here called count, also set to 0. Right. Every time they enter a number and we total it, we should also increment our counter, don't you think?
Because it's
And if we want to,
how many times it's used, right?
Say that again, Anthony, a little louder.
Because it's counting how many numbers are being entered or used, correct? To make that
precisely. And all right, so but when do we do? Okay, we're not going to output the total sales, obviously, but when do we calculate the average inside the loop? No, we would do that after. And notice how Visual Studio just knows the right answer there. We do it after the loop is done. And then we can output the average. And we can get into our console right line here. And I'm not sure how you guys want to say this, right? We can say it a number of different ways. And maybe we string interpolate here, I think would be wise. How about the total is total. Let's do a new line. And then we'll say the total number of numbers entered was count. And then we'll do another new line in which we'll say the average is AVG. Oops. And I should have just pressed tab when the right output was on the screen. All right, but you see, I'm just doing it all in one statement. All right, let's try running this. Here comes the run. And I will move it off to the side of the screen here so you can still copy your code. All right. So, all right, I'm going to be snarky and just enter -1. All right. Now notice, all right, it's having a problem with this now, right? Because it cannot execute this code if I have nothing here. What's the problem? Well, if the count happens to never be incremented, I'm dividing by 0. See the problem with that? Yeah, that's not allowed. So what I should do is if count, and I apologize, if count, sometimes autotype is wonderful, sometimes it's horrible. If the count is not equal to 0, correct? Is that the right logic? Then we'll compute. Is that enough to fix it? Yeah, that should be enough to fix it. All right, so it did crash here, so I'm going to Control C. It won't let me even. All right, I have to hit continue in the program. All right, let's try it again. Let's try the -1, see if I can break it. Okay, better. Right. Now let's do it with a real number. Right, so this time I'm going to enter something real, like 1. So asking, is this the correct output?
Yes.
Okay, Grayson's shaking his head no. Teresa's nodding yes. Anthony's sure his count's going to be off by 1. but is this the correct answer? Well, you can pull out a calculator and add these together. Okay, now Grayson, you were shaking your head. Why is this not the correct output?
The total number that we got for the output is wrong. It's off by 1. It should be 11.
Ah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Wait, sorry. Yeah, sorry, not that. The average. I was missing which. I was thinking in my head the average is off because that should be a decimal.
Okay. So something's happening to the average there, even though we're setting it as a double. But what's happening here? We have a count and a total.
Right.
So maybe the problem is here.
Do you have to convert the total into and double?
Yeah, I think we have to cast it to a double. And if I'm not mistaken, I think we just do this. or no, wait, I'm trying to remember how to do this in C#, so I apologize. So here's
The parentheses is around the double.
yeah, right. Like so. Let's use the same numbers. Now, the reason I use these numbers all in a row is not accidental. I happen to know what the answer is. that's why I did it, right? Because I know if I add first 10 numbers together, it's 55. I know that, right? Now we're going to type a -1. Now is it correct? Yes. All right. Different ways we could have handled the issue on that, but yeah, we don't need that using statement up there, by the way. But that, I think that's a nice little example. And like I said, this one might come back to prove useful later, you know, and that's one of the reasons why we do this. And by the way, all right, so we did the little tryouts here. All right. I think that this is another good spot to take a break. We've been going for almost another hour already. It's pretty amazing, right? Let's do another 5-minute break, folks. So let's come back at 8:49. Pausing the recording. All right, welcome back from break. We're now going to move into the last couple segments here of the night, which is to finish off talking about loops and some of the stuff that we use with loops. The next concept we're going to look at is nested loops. And they use kind of an interesting concept here. Now, we've already learned about, for example, nested if statements, right? Where I can take an if statement and put it inside of an if statement. And we can do the same thing with loops. So if you were getting confused about how many times a loop runs when you just have a singular loop, can you imagine the confusion it might cause if you have a loop inside of a loop and maybe a loop inside of that one and maybe a loop inside of that one? Right. Conceptually, what happens is it's difficult, real frankly, it's difficult for our brains to wrap around that and understand it, you know, and it's not abnormal. But we use the analogy of a clock to sort of explain how nested loops work, because this is something we tangibly get and we deal with every day, and we don't think about it. We just kind of take it for granted. But this is really an excellent example as of nested loops. So for example, think of a clock. The hour is 1, right? So we have a loop of hours. How many hours do we have in a day? 24. When those 24 loops run out, what do? We start over again, right? And really, the clock doesn't go up to 24, it goes up to 12. So really, we're looping on 12, right? And then every time we loop an hour, inside the hour, we're looping the minutes. And then each minute we're looping the seconds, right? So you guys feel what I'm saying about that, right? So there's a loop inside of a loop. And then if you really want to go in further, well, inside the second, we're looping the, you know, microseconds or milliseconds, you know, is like, you know, and if you're a musician, you know what I'm talking about, right? Because we usually count out a second in milliseconds, and it's perceptible. You know, something as short as 1/10 of a second is actually perceptible to the human ear and eye in terms of when something happens. So the point is, the hour is 1, we count through the minutes, the hour goes up to 2, we count through the minutes, so it's a loop inside of a loop, right? So if you were to look at it maybe as a nested loop, right? How it says, how could we implement the minutes going from 0 to 59? Well, we could set up a for loop, start at 0, and we count up, well, almost to 60. We count up to 59, and every time it runs, we add 1, and it'll show the minutes. So in other words, if I ran this loop, it would go 0 to 59, and then it would start over, like a clock does, right? So the loop to control the minutes should repeat. How, right? If you want to like put it in the context of an hour, then you put it inside of another loop. And how many times do we want the minute loop to repeat? Well, every hour, right? So every time it loops all the way through, it's 1 hour's worth of minutes. And then it depends on how many hours we want ultimately, but the loops end up sort of looking like this, right? Now, why are we using for loops for this? The reason we're using for loops for this is because for loops are controlled. We know what the count is in advance. I don't have to prompt somebody for the values. I know what the values are. And so here's an example of a 60-minute loop operating inside a 24-hour loop. Every time I run the outer loop, and this is the terminology here, so this is the outer loop. So for the 0 hour, what do? We go into the other loop and count through the minutes. When we're done counting the minutes, then we increment the hours by 1, so then it becomes 1 a.m. Then we do the minutes, and then it becomes 2 a.m., et cetera, et cetera, et cetera. And if we wanted, right, we could put another loop in here for seconds. And conceptually, that's weird for our brains, because if we didn't have the analogy of the clock, you would not think of a lot of scenarios in which you would loop instead of a loop, much less take it to the third level, right? Now, you could also expand the loop the other direction. So let me have you think about this, because this is how time operates, right? Well, there's 24 hours in a day. So we could have a month loop or a week loop or a year loop, if you feel where I'm going with that, right? These are all amounts that we know. And so our loop could fit into a week loop, which fits into a month loop, which fits into a year loop, which fits into a decade. You see where I'm going with that? So the concepts really aren't that hard. Now, to code all that, yeah, that would be a little bit of a process, but a loop inside of a loop is a common and useful tool, especially when we're dealing with complex objects. We don't think of the clock as being complex, but it really is, right? It's a complicated construct. All right, so a nested loop says the inner loop goes through all of its iterations for each iteration of the outer loop, right? How many iterations total will happen? Okay, well, we multiply the outer iterations by the inner iterations, and it'll be for a 24-hour, 60-minute thing, it's going to iterate 1,440 times, right? And we can predetermine that because we can just multiply the two numbers. We know this loop's going to run 24 times. That one's going to run 60. So for each one of the 24, we have 60 iterations. Yeah, 24 times 60 totally makes sense. So I know it's going to be 1,440 iterations. Right. Little warning at the bottom, be sure to use different loop control variables for the outer and inner loops. Yeah, makes sense, right? We don't want to count. If this is hours, we're counting hours. If this is minutes, we're counting minutes. If we put another loop inside of it for seconds, it's going to count seconds. All right. Another interesting usage for nested loops, and a very common usage, is when we're dealing with tabular data, or like the rows and columns of a spreadsheet, right? So it says here it's very common to use nested loops, especially in the console programming, to print a table. So in other words, I can start a row, I can print the first, second, third column, and so forth. And then when I'm done, start the next row, print the same columns, next row, print the same columns, and keep going, right? So this is actually kind of an interesting question here at the bottom then. Which is the outer loop and which is the inner loop? Well, okay, it's pretty easy because we got one iteration of a row and then we do a whole bunch of columns. So this is the inner loop. This is the outer loop. Then we do another row, right? And notice these aren't numbered, but you could say start a row and you could like number it. You could say 1, start a row, 2, for example, 3, and you can tell that the row part is the outer loop. See what I mean? Right? So that's how you can kind of make that determination. Here's an example of a case use scenario, right? Where a multiplication table kind of becomes one of these, right? So we have rows and columns and they're numbered. And what are we really doing? We're multiplying the rows and the columns together, right? So 1 times 1 is 1, 1 times 2 is 2, etc. Here we're only going from 1 to 4 in columns and rows, but if we took that all the way out to 10, we could have a regular multiplication table, kind of like the one you learned in grade school, right? That you were supposed to memorize. Right. And I hope you did, right? It does make math a lot easier for sure. But and this is kind of a sideline question. And I'm asking this of all the younger people, here in class or watching the video. Are you guys still taught the multiplication table in school? You expected to memorize it? I ask that sincerely. Nobody here wants to give me that answer, right? You can put it in the chat if you don't want to answer it verbally, right? Because I don't think, and I think what happens is a lot of people are like, oh, I never learned that. What was I supposed to? And I think that's what's happening now because people have calculators in their hands. But when I was a kid, I was expected to know this stuff by like 3rd grade or 2nd grade or something, right? And there's still a couple in the table I kind of like fudge on or whatever, but for the most part I do know it and I know how to figure it out. But knowing that multiplication table I think is important. All right, so the point is, all right, going back to the loop inside of a loop concept, when we're doing rows and columns, once again we already determined the rows were the outer loop, and I'm trying to click on the text, right? So you see on the outer loop we're keeping track of the rows. You can tell in the inner loop, we're keeping track of the columns, right? And then notice here that they're setting up constants for rows and columns, right? I think this is an interesting, let's drop this one into the IDE and see what it does. All right, I just want to show you what it looks like. So let's take this over to Visual Studio. I will highlight everything and paste it back in. And notice here, rows and columns are being set as constants. So this could be hard coded to 4. That could be hard coded to 4, by the way. For every time it goes through, for each row, it will output 4 columns, right? And then it'll multiply the values and then put in some space. All right, well, let's just run this so you can see what it does. So that's for every iteration of the outer loop. And notice it 1, 2, 3, 4, 2, 4, 6, 8. Is this correct so far? That's pretty correct. Now, if you want to make a really nice looking multiplication table, you can write logic in here so that if the numbers are, for example, less than 10, you can add an extra space. Or if they're less than 100, add 2 extra spaces, that kind of thing. Right, so make it line up real nicely. But I could extrapolate this out to a 10 by 10 grid if I want by just changing these 2 values. And yeah, that gets a little ugly looking, but it's doable. You get clever and you put a couple of if statements in here, right? So you can, so in other words, if it's a single digit number, you probably want to add 2 spaces, maybe 3 spaces between each character. If it's a 2-digit number, you want to add 2. And if it's a 3-digit, you only add 1. And you can write the code for that. And then you can make it look very pretty if you wish. But the concept, the proof is here, right? It shows that this is the one line of output is one iteration of the outer loop, right? Every time I do the outer loop, I come to the inner loop and I run it the required number of times, 10 times. So I go all the way across. Each time I'm multiplying by the row number. So the first row is always multiplied by 1. The second row is always multiplied by 2. et cetera, et cetera, et cetera. And that, I don't know, this is a nice example too. I like the multiplication table example because it makes sense, right? It's something we know once again. So when you use an analogy like a clock, or you use an analogy like a multiplication table, the loop inside of a loop, the nested loop, is not a really foreign concept. It is actually pretty logical. All right. Now you want to try something weird, right? And so this is this is like goofy stuff that like programmers often are forced to do, is like, how do we generate patterns like this, right? So if I run a loop and I want to output 1 star, then 2 stars, and 3 stars, how do I do that? Are these really nested loops? Now in Python, I could do this without a nested loop, right? If you guys know Python at all, it's got like these goofy little things that you can do. But with C#, and I'm not going to go into coding this, by the way, right? You could if you wanted. How would you generate this? What would the code look like? What would be the outer loop? Do I need to code it to show you? I should say yes.
Yes.
Yeah, you should say yes just because, right? All right, let's get rid of this stuff. And then I don't know what we're going to call this. Let's just call it X. X equals 1. And as long as, how many of these are we doing total? 7. How many rows? 1, 2, 3, 4, 5, 6, 7. 7 rows by 7 asterisks. You see, I'm changing everything to X. The outer one is X, right? And then the inner one, let's call that Y. Let's set that also to 1. And then we're going to run it from Y to what? Well, we'll go to 7. And yeah, we could set these a different way. I'm just hard coding the values just to make it a little easier. And then what are we writing? Would this work? This is my output. What happened? Well, it did exactly what I told it to do, right? The first time it ran the outer loop, went to the inner loop, which outputted 7 stars. Then it went to the next loop and outputted 7 stars, and it just kept going. It just kept doing the same thing over and over again. So it did exactly what I told it to do. I want you guys to notice though, here in the next slide, right? Well, all right, that's not where we're going. So how can I make it so that every time it runs through the loop, it prints more? Well, how about instead of hard coding the 7 here, so the inner one always prints 7, I hard code the X instead. First time through it's 1, next time through it's 2. Right. So this is where like the loop mechanics get kind of interesting. Kind of cool, right? So these are fun little exercises, and you guys might feel like they're more torturesome than fun. Real frankly, it's like, what do I really have to think about this? It's like, yeah, you should, right? Because understanding how it works really gives you a leg up on the whole mechanics of loops, right? Now I get it. Some of you are completely brand new to this concept and it feels overwhelming. You can always refer back, by the way, but it is a process of trial and error to try to figure out how to make these patterns. And they're kind of fun, actually, too. And you should look at it as puzzle solving more than anything. In this one, what is it doing? It's printing a pound sign and then a space and a pound sign, then 2 spaces and a pound sign, et cetera, et cetera, et cetera, et cetera. How would I accomplish that? Do we want to like not put our brains there? If you want to try something fun though, try to do that one. That's kind of an interesting one because you would intuitively say, all right, that we could sort of follow the same pattern. Sort of follow the same pattern, right? So we would change that to a pound sign because it's going to output that every time, no matter what. How would we make it output a different number of spaces preceding this? So the first time through, we would output just this. Do we need another variable? Do we need a counter?
Probably a counter.
Yeah, this is kind of
Take
an
up
interesting.
space.
All right. I'm going to do something really goofy here because I'm far too lazy to type this, but I just want to show you guys that people do this, right? Yes, they go to Chat GPT. Oh gosh, can I do this? Yes, I can. All right, let's see what it comes up with. And I do not want you doing your homework this way, by the way. No, not exactly the answer you're searching for. Look at where it's printing the hash mark on this. So it lets, so the hash mark is printed with the outer loop because that happens every time. What's changing, see, this is a matter of recognizing what the change is, right? The change is really in the number of spaces. So each time we're printing more spaces, but wow, right? The concept is really simple. It's really a matter of recognizing what the problem is, so this goes back to like some of the fundamental precepts that we have in programming, because this always prints, so that could be part of the outer loop. Makes sense, right? Always prints. What changes is the number of spaces. We start at 0, then we go to 1, 2, 3, 4, 5, 6, and then we're done. Some more patterns here. Let's try this one. Use nested loops to display a 3x3 grid of asterisks and spaces. Oh, we already did that, didn't we? Except ours was like 7x7. All right. Right. If you wanted to like ramp it up, you know what? I'm not even going to do it, but you could ask the user for an integer width and then use nested loops to display a grid of asterisks and spaces that is 4 rows high and the width that was provided by the user. All right. Well, all right. I'm not going to do it. I'm just going to save the time on it. But if you did the 7x7, all you have to do is alter that with an input that would change the value of one of the loops, the limits of one of the loops, right? The inner loop would get the value entered by the user, and that's how you would do it. All right. So in the interest of time efficiency here, I'm trying to get through the rest of the slides so we can call it a night, which I'm sure you guys will appreciate. Last topic that we're going to hit on tonight are these two keywords of break and continue. If you guys recall, when we learned how to do the switch case statements, every time we hit a case inside of a switch, we would execute some code and we were required to include the break statement to get us out of the switch statement, right? So that's where we're going to start here. We'll talk about the break statement. And so it reiterates that exact thing. So we saw that we use that in switch statements, and it basically forces you to exit the block of code that is the switch statement. And that's done by design. We don't want to, like, if we hit the case that's correct, we don't want to keep processing. There's no reason to, right? And if if it's a really long, exhaustive list of cases inside the switch, it makes sense. Why would we want to process that if we've already hit the right solution? The point here is we can also use a break inside of a loops body, and that can cause us to exit a loop also. So for example, I can have a while loop that I know is going to run infinitely, and then I can set up an if statement in there so that if a certain thing happens, I can drop a break into it and jump out of a loop, right? And that's just one really kind of weird scenario. Let's take a look at this as an example. If we ran a randomness tester, right? So we generate random numbers between 0 and 1 forever. How many numbers you've generated should be counted, right? So we would count that. If a random number is less than 0.1, stop. So the point is, we'll generate random numbers until we get a number in this range, and then we'll quit. Now, on average, how many times would this run before we'd get a number in that range? Well, the thinking is, on average, it'll be 1 out of 10 times, right? So 1 out of 10 times, it'll stop after the first iteration. Or it could, in other words, the probability of it stopping anywhere along the way is 1 out of 10 times. At most, logic would dictate 10 times before that would hit, but maybe it'll go longer. We really don't know. All right, so this is kind of the setup scenario. All right, so this is kind of a weird thing. We're taking a while loop here, and I want you to notice this technique, because this is actually seems like a dumb thing to do, but I taking a while loop and I'm just putting the keyword true in the condition. Weird, right? Now, if I don't look at any of the other code in here, there's nothing I can do inside of here to make it pop out of this loop. This loop will never stop because the condition is true. It's hardwired to true. It's like loop on, go. It's like having a car with a gas pedal and no brake, and the gas pedal is pressed, and you have an infinite supply of fuel, right? It'll just keep going and going and going. But notice the logic here. We are going to generate a random number, right? And then we're going to check it. If the random number happens to be less than 0.01, break out of the loop. Otherwise, we'll count and we'll see how many iterations it made. I think this is kind of a fun one to throw in the IDE, so I'm going to do it. First, let's terminate that. And let's drop the code in here. And let's give it a run. Kind of interesting, because it happened so fast you don't even get a chance to see it. It ran 7 times before it hit that loop. Right? Let's run it again. You should, in principle, get a different number each time. So this time it took 19 times to get into that range. One more time. 7. What should be the average number of times? Like if I ran this loop, if I put this loop inside of another loop and ran it a whole bunch of times, how many times on average would the loop run before the condition hits? Well, it's 1 out of 10.
These two.
Yeah, it'd be 10. I know it's like overthinking it, but I think it's kind of an interesting little thing. The point is, you can hardwire a loop to run and then come up with a condition inside of the loop to break out of the loop. So you don't have to even worry about the logic here. You can set up a situation here to get a person out. So for example, I could even put a user prompt in here to break a user out. And we'll do that in some of our programming, by the way. Now, there's a sister statement to the break statement called the continue statement, which causes the loop to exit early, right? Okay, but let's read the difference. Break makes the loop quit entirely. No more iterations. You're just out. Wherever you are in your code, you're out of the loop. onto whatever's below the loop in the code. No more iterations, doesn't even finish the current iteration. Continue ends only the current iteration. So it'll interrupt whatever's going on in that block of code, but then it goes back and starts over again with the next iteration. All right. So here's the randomness tester version number 2. So this is generate 100 numbers between 0 and 1. How many of them are greater than 0.1? Probability says it should be 90%. Okay, right. So this is kind of the converse here. So let's look at where this code takes us. So in this one, we are once again setting up a for loop, or not a for, okay, last time we did a while loop, this time we're doing a for loop. We're forcing it to run 100 times, right? We're going to run a random number. If the number is less than 0.1, we will continue. But notice what it's going to do. It's not going to count. So what this is doing is it's going to do a count of how many times it runs and doesn't hit 0.10. Because in other words, if I hit continue, the loop stops here, the counter will never hit. It just goes back up and starts over again. Right? So it's kind of stopping the loop here in this iteration. So in other words, it's breaking the iteration, it's not breaking the loop. The loop is hardwired to run. I think this is a fun one to run too. So let's just go ahead and copy paste it into the IDE and try that. So this is kind of a neat little program here. Right. So 92 times it ran. So in that instant of a second, it ran 100 times. 92 of those times it was not less than 0.1. Run it again. And yeah, I could set up loops inside of loops to prove it, but each one of these times it might not be exactly 90, but I will tell you it'll be within a range of really close to 90, because that's what probability tells us. Chances are it'll be within 3, 4, 5 numbers greater than or less than 90, right? Just from probability. Right. But it is random, so we can't ever predict it. All right, folks, that ends our lecture part of module 4, talking about all these different topics. So this recording ends here. And I meant to hit the stop